Let's take a look at exercise 30 in chapter 15. It appears that people who are mildly obese are less active than leaner people. One study looked at the average number of minutes per day that people spend standing or walking. Among mildly obese people, the mean number of minutes of daily activity, standing or walking, is approximately normally distributed, with mean 367 minutes and standard deviation 64 minutes. The mean number of minutes of daily activity of lean people is approximately normally distributed, with mean 522 minutes and standard deviation 110 minutes. A researcher records the minutes of activity for an SRS of 6 mildly obese people and an SRS of 6 lean people. Use z-scores rounded to 2 decimal places to answer the following. What is the probability that the mean number of minutes of daily activity of 6 mildly obese people exceeds 420 minutes? And also, what is the probability that the mean number of minutes of daily activity of the 6 lean people exceeds 420 minutes? Well, to begin with, I'm going to draw myself a diagram, right? So having a visual of a bell curve can help us get an understanding here. One thing we know for both samples, we're dealing with 6 samples. Let's see. What's the probability that the mean number exceeds? So we know we're looking for an area on the right of the mean because it exceeds an X value here of 420 minutes. So this is X. And for the mildly obese people, we are looking at a mean of 367 and a standard deviation of 64 minutes. If you recall, we need z-scores to find areas using table A. All right, z-scores were x minus x bar, or mu, but x minus the mean, divided by standard deviation. But we're in chapter 15 right now. We're dealing with the central limit theorem. We're talking about the mean of a bunch of samples, right? And we have 6 samples, the mildly obese people. And let's see. Let's take a look then at finding z, because after we find z, we can find a. So x is 420 minutes. The mean is 367 minutes. And we'll divide by 64. Oops. I'm going to go erase that. Oh, yeah, because I couldn't see it. 64, which itself is divided by the root of 6, right? So 420 minus 367 gives us 53, divided by the quantity of 64 divided by the square root of 6, which equals 2.028, which is a 2.03. And that's the z-score of this 420 right there. And now if I look at table A in the book, which for me is the back page of the book, and I look for the 203, then what I'm looking for is on the column, I'm looking for the 2.0 in the row, and then you're trying to find a column then that has 0.03. So find the row with 20 and the column with 03, and we get right here. I drew it a little too small. We got a 9788, 0.9788. But what that number is from table A is actually the value of the area to the left. So the area to the left is 0.9788, which means the area on the right is 1 minus 0.9788. So 1 minus 0.9788 is, I'm getting 0.0212. What's the probability that the mean number of minutes of daily activity of the 6 mildly obese people exceeds 420 minutes? That's 0.02 there, 0.0212. All right, and the same sort of thing applies to the second problem. What is the probability that the mean number of minutes of daily activity of the 6 lean people exceeds 420 minutes? Same picture, same table, same Z formula, but different numbers, right? So here Z is going to equal X minus mu over sigma divided by root n, which equals, here X is still 420, right? 420, but now now we're looking at a mean of 522 and a standard deviation of 110. So 420 minus 522 divided by 110 divided by the root of 6, still the root of 6. And plug and chug it through your calculator. We get 420 minus 522, a numerator of negative 102, divided by the quantity 110, which itself is divided by root 6, which gives me a z-score of negative 2.27, which makes sense because 420 is less than 522, so we should have a negative z-score right now. Again, sorry about that. For our table now, right, we're going to go to our table. I'm gonna erase the red bit here. Okay. If we go to our table, this time we're going to a row that reads negative 2.2 and a column that reads 0.07, right? So go to your table A, go to the negative 2.2 in the row, then find the column 0.07, negative 2.27, oh, that's a 1, 2.27 gives me an area of 0.0116. But again, this is the area leading up to, which now in this problem is, ooh, there we go. We are looking for, what's the probability that the mean number of minutes of daily activity of the 6 lean people exceeds 420. So this time 420 is below the mean. We're going to end up with a large probability. All right, so this time the area we found is 0.0116 on the left side, but we want the area on the right side. So we want A, erase some of this stuff in here, so a little space. Okay. We need A, which equals 1 minus that 0.0116, which is 1 minus 0.0116, 0.9884.